In this lecture, I want to discuss a famous principle regarding identity, a principle known as Leibniz's law. This principle is sometimes also known as the principle of the indiscernibility of identicals. And what this principle says is that for any x and any y, if x and y are identical, then whatever properties are had by x are also had by y. I think that this is a self-evident principle. So if x and y are in fact identical, then x and y are one and the same thing. So whatever is true of x is also true of y, and vice versa. Why? Because they're exactly the same thing. And our system itself vindicates this principle on account of the fact that the following turns out to be a theorem in our system. For any x and any y, if x is identical to y, then if x is f, then y is f. That's a theorem in our system. So take any property whatsoever, let f be a predicate that expresses that property. Our system tells us that if x and y are identical, then whatever property x has, then y has that property as well. Okay, as I said, I think this principle is self-evident, but it often plays an important role in philosophical arguments. So philosophers will often appeal to Leibniz's law in order to argue that things that some people believe are identical are actually distinct. So I want to consider a highly controversial example of such an argument. So consider the following argument for the conclusion that I am not identical to my body. Now, some people, including many philosophers, believe that human persons are identical to their bodies or to some other material thing, maybe a brain or something like that. And other philosophers think that's not the case. Other philosophers think that human persons are some sort of immaterial thing, maybe a soul or something of that sort. Well, I'm not going to settle that dispute here in this lecture, but I do want to look at an argument for the conclusion that human persons are not identical to their bodies. And I'll put this as an argument for the conclusion that I'm not identical to my body. Here it goes. I could survive the destruction of my body. My body could not survive the destruction of my body. Therefore, I am not identical to my body. Okay, well, why think the premises of this argument are true? Well, the second premise, my body could not survive the destruction of my body, that seems obviously true. A thing can't survive the destruction of itself. So that premise is perhaps relatively uncontroversial. But what about this first premise? I could survive the destruction of my body. Well, why think that premise is true? As a matter of fact, a lot of philosophers who are inclined to reject this argument will reject this premise, but there are some things to be said for this premise. You might think that maybe it's not possible in some natural or physical sense that I could survive the destruction of my body, but it's at least possible in some sort of logical sense. You might think that because it's at least conceivable that I survive the destruction of my body. I can imagine, say, waking up one morning and discovering to my surprise that my body's gone. I'm there. I appear to be sensing my environment, but I have no body. Now, you might think, yeah, that couldn't happen given the laws of nature, but it's at least a coherent scenario. It's at least possible in a logical sense that that could happen. There's no contradiction in the story that I just told. So that might be a reason to believe that this first premise is true, that I could, at least in some logical sense of possibility, I could survive the destruction of my body. Now, as I said, this argument is highly controversial. Many philosophers are inclined to reject it. They would deny the first premise, or many of them would deny the first premise. Others would deny it for different reasons. But at the very least, we can see that according to our system, this argument is, in fact, valid. So if I let C abbreviate, could survive the destruction of my body, and I let K be a name for myself, and M be a name for my body, I could represent this argument as follows. CK, it is not the case that CM, therefore it is not the case that K equals M. And this sequent is valid. I will give you the opportunity to prove that it's valid in your homework. Now, my point here is not to convince you that this argument is sound. I just want to show you how Leibniz's law can figure into an argument for a controversial conclusion. But not only does Leibniz's law figure in arguments for controversial conclusions like this, it also figures into certain kinds of philosophical puzzles. So I want to look at an example of such a puzzle. Puzzles of this sort often arise because things that we're inclined to think are identical often seem to have different properties. So consider a statue made of a lump of clay, for example. We might be inclined to say that the statue is identical to the lump of clay. So imagine the statue sitting on the shelf, and there are no other objects on the shelf. At least that's what we might initially be inclined to say. Now it seems at the very least that there's only one statue-shaped object on the shelf where the statue is now, not two. It would seem bizarre to say, well, there's actually two statue-shaped objects right there on the shelf. There's the statue, and then there's the lump of clay that the statue is made out of. That seems false. It seems like there's only one object there. It seems like the statue is identical to the lump of clay. But there is an argument for the conclusion that the statue is not, in fact, identical to the lump of clay. So imagine that this statue has just been made. The lump of clay has not yet hardened. And consider the following argument. The lump could survive being squashed. Well, that seems true. If we squashed the statue, we'd still have the lump. If we squashed the lump, it would have a different shape, but it would still exist. But the statue could not survive being squashed. If we squashed the statue, we would have destroyed the statue. It would no longer exist, even though the lump of clay would still exist. So we have this argument. The lump could survive being squashed. The statue could not survive being squashed. Therefore, the lump is not identical to the statue. We could represent this argument as follows. CK, it is not the case that CS. Therefore, it is not the case that K equals S. Well, what should we say about this puzzle? Well, actually, there is a lot to be said about this puzzle. There is a surprisingly large body of literature on the part of philosophers devoted to this puzzle and very similar ones. I'm not going to tell you in this lecture what the right thing to say about this puzzle is. It's controversial what the right thing to say about the puzzle is. What I wanted to do in this lecture, though, is just point out how puzzles like this can arise on account of Leibniz's law. Okay, now that we've explored Leibniz's law a little bit, I'll go ahead and allow you to do a couple of proofs that reinforce some of the concepts in this lecture.